Let's talk about linked lists versus binary trees. This is going to be a video with code and conceptual material inside of it. So first, the conceptual material, to get that out of the way, let's talk about basic linked lists. Remember that linked lists are essentially two nodes. So we have one here, and then we have one right next to it. Now, the first one, because these two are basically together, right? It's one node, kind of two parts. The first one is going to be any data value that's stored in this node, and this next part is going to be the pointer to the next node. And then we would just repeat this essentially. So we would have another block here for our data. I'll just put D here, and then we have another block here where it's a pointer to the next node. So this is how we would have a linked list. Binary trees are somewhat similar to that, but they're going to have two links. So if we have our binary tree, I'll just do BT like this, not Bluetooth, binary tree. You're going to have a block right here, and this is going to be your data. And then underneath your data, you're going to have another block here and another block here. Now, these are going to be your left and your right, and they're going to point out. And these can link to new blocks. So we could have like a new block here, and then this could be our D for data. We could split this into left and right, and then we're gonna keep going on. And this just repeats recursively until you finish loading your binary tree with data. Let's make a class for our binary tree. It's going to be a public, and we'll call it class, and it'll be an int tree node. So it's going to make nodes for an integer binary tree. Because I have a public class main, I'm using all one file. This is just going to be a class inside of here. So class int tree node. But if you made another file like in your SRC, you would make it public. There's three data types in here. It's going to be a public int. You can always change the public to private, but just for simplicity, we'll have public int data. That's going to be the head of our data. And then we are going to have the links. Remember, we have our data up here, and then we have links to the left and right. And then for this one, because it's a linked to a new int tree node, it's going to be a public int tree node, and we can call it left. And then we can also make a public int, oh, make sure you spell this correctly, by the way. I spelled int. This should be int tree node, and then we should have right. So these are going to be our three variables inside of our class int tree node to make this left and right, and also store our data. If we are given some kind of data that we want to add into our int tree node, we can easily do that with a constructor. So we'll have public int tree node, and then inside of here we are going to take a data value. So it's going to be data, and of course we know it to be type int. We have this int data right here, and we're going to do this dot data is equal to data. So we're setting this data value to be this data value that's passed in, and we're also going to want to set these to null. We're going to set this dot left equal to null, and then we're going to set this dot right equal to null as well. That way we have everything initialized, even though nothing is passed in here. It's important to do so. If you are past left and right values, that's totally fine. You can make a constructor for that as well. Public int, and then we'll do tree node. Inside of here, we'll pass in int data. We're also going to have to pass in an int tree node right, and also an int tree node left. Oh my goodness, I really can't spell. All right, so inside of here, you're basically going to have the same thing as this, except you're given values. So instead of passing in null for left and right, you're going to want to pass in left and right. And that's pretty much it. This is how we would make a basic int tree node. You have these three variables, you have these two methods to initialize everything. It's very simple, just like the linked lists, except here we have two links to data values, where with linked nodes we only have one. Like linked lists, we can reach every node by starting from our root. Remember, there's only ever one overall root. However, using recursion, you'll see roots be used as a argument that's passed into our methods, and it's done just for simplicity. It's important though to distinguish what's called a root here from the overall root. We'll build onto this code and talk about more concepts and future videos, make sure you check those out in the playlist, link below the like button. If you have any questions on any of this material, leave a comment below and let me know.